Hi, this is Selvapriyan. Today let's see 2013 gate surveying problems. So first question, the latitude and departure of line AB are plus 78 meter and minus 45.1 meter respectively. The whole circle bearing of the line AB is. So the latitude and departure of line is given and they have asked to find out whole circle bearing. We have already discussed the formula for latitude and departure and we have already derived it also. So the latitude L is equal to capital L is equal to length into cos theta, L cos theta, that is equal to 78 meter, and departure D is equal to L sin theta, and it is equal to minus 45.1 meter. So we want to find the bearing, that is theta. So if we can divide departure and latitude, or either latitude by departure. So if we divide latitude by, so I am dividing departure by latitude, that is D by L is equal to L sin theta divided by L cos theta. So we will get sin theta by cos theta, that is equal to tan theta equal to minus 45.1 meter divided by 78 meter. So we will get minus 45.1 meter divided by 78 meter minus 0.578. 0.578. So theta is equal to tan inverse of minus 0.578. We will get, after substitutions, we will get theta is equal to minus 30 degree. Minus 30 degree. But this is not the answer. Uh, Look at the signs of latitude and departure. Latitude is in positive and departure is negative. So this lies in the fourth quadrant. We know north is plus latitude, north is plus latitude, and south is negative latitude, and east is positive departure, and west is negative departure. So the latitude is positive and it lies on the north side, and departure is negative, so it lies on the west side. So this lies on the fourth quadrant, that is, it lies on northwest. Northwest quadrant is fourth quadrant, and theta is equal to 30 degree. So therefore, the theta we have calculated is 30 degrees, lies on the fourth quadrant, and it can be written as north 30 degree west. But the question is asked in whole circle bearing. For whole circle bearing, we calculate theta from north to the line in this direction. In clockwise direction, we calculate theta in whole circle bearing from north. So the theta is equal to 360 degree, 360 degree minus 30 degree, minus 30 degree, and it is equal to 330 degree. So option D is the right answer. Option A has 30 degree, but it is not the right answer. It is wrong. We have to look at the signs of latitude and departure. Suppose if the departure is also lies on the positive axis, that is on east side, the answer will be theta is equal to 30 degree. It will be the right answer. But the departure lies on negative side, that is on west side. So we have to calculate whole circle bearing separately. So the answer for this is 330 degree. Next question. Following bearings are observed while traversing with a compass. And lines are given, forward bearing and back bearing of those lines are given. After applying the correction due to local attraction, the corrected forward bearing of the line BC will be. So after applying the correction due to local attraction, so that means it indicates that the line has some local attraction. The corrected forward bearing of the line BC is given. BC is asked. From the question, it is very clear that the line B, the station B and C has local attraction. So we have to find out which stations are free from local attraction. To find that, we know that when the station will be free from local attraction. Local attraction means the difference between back bearing and forward bearing will be exactly equal to 180 degree. If the difference between back bearing and forward bearing is exactly equal to 180 degree, it indicates that the line is free from local attraction. So let's find out the stations which are free from local attraction. So B and C are the stations which are affected by local attraction. So the lines which contains either B or C also affected by local attractions. So we can't get that 180-degree difference. So the line AB has B station. So it can't be free from local attraction. So we neglect the line AB and BC and CD also we are going to neglect because the CD has C station is present in that. So it can't be free from local attraction. So let's look at the line DE and EA. So DE is equal to the difference between back bearing and forward bearing or either or forward bearing minus back bearing or forward bearing minus back bearing equal to so 258 degree 30 minutes minus 78 degree 30 minutes is equal to exactly equal to 180 degree exactly equal to 180 degree. So D and E are free from local attraction. Now look at EA. Look at the forward bearing and back bearing of the line EA. It is not equal to 180 degree. So that means EA has some local attraction and we have to find that. As D and E are free from local attraction, EA is correct bearing. EA is equal to 212 degree 30 minute 30 minute is correct because forward bearing of EM is nothing but bearing of A with respect to E. Bearing of A with respect to E. As E is free from local attraction, forward bearing of A is correct. So now the back bearing of EA will be wrong and we have to correct that. Actual actual back bearing should be actual back bearing of EA will be 212 degree 30 minute minus 180 degree will be equal to 212 degree minus 180 degree will be equal to 36 degree 30 minutes. But in question it is given 31 degree 45 minutes. So the error is equal to 31 degree 45 minutes minus 36 degree 30 minutes is equal to minus 4 degree 45 minutes. Minus 4 degree 45 minutes is the error. The error is negative, correction will be positive. So correction is equal to positive 4 degree 45 minutes. It is nothing but we have to add 4 degree 45 minutes to the back bearing of EA. So correct back bearing is equal to actual correct back bearing is equal to 31 degree 45 minutes plus correction, that is correction 4 degree 45 minutes will be equal to, we have already derived that is 36 degree 30 minutes. 36 degree 30 minutes is the correct back bearing. Therefore correction applied is plus 45 degree plus 4 degree 45 minutes at A. At A it is applied. Therefore correct forward bearing of AB is equal to correct forward bearing of AB will be forward bearing of AB is bearing of B with respect to A. Bearing of B with respect to A. So it will be equal to 126 degree 45 minutes plus 4 degree 45 minutes. Because in back bearing of EA, E is free from local attraction and A is affected by local attraction. So the corrected A station is plus 4 degree 45 minutes. And at forward bearing of AB, we are applying that correction, that is 4 plus 4 degree 45 minutes at forward bearing of AB. So it will be equal to 131 degree 30 minutes. 131 degree 30 minutes. And therefore correct back bearing of AB will be 180 degree plus 131 degree 30 minutes and it will be equal to 311 degree 30 minutes. 311 degree 30 minutes is the correct back bearing of AB, but the given is 308 degree 0 minutes. So the error will be 308 degree minus 311 degree 30 minutes. It is equal to minus 3 degree 30 minutes. So the correction is equal to positive 3 degree 30 minutes. And the question asked is correct forebearing of BC. Correct forebearing of BC means we have to apply correction at station B, and we have derived the correction at station B is plus 3 degree 30 minutes. Therefore, the correct forebearing of BC will be 49 degree 15 minutes plus 3 degree 30 minutes. Correct forebearing of BC will be equal to 49 degree 50 minutes plus 3 degree 30 minutes equal to 52 degree 45 minutes. 52, 52 degree 45 minutes. In question is given wrong. That is, in question it is not 49 degree. It is 45 degree 15 minutes. That is a correction in question. 45 degree 15 minutes is the correct question. So it will be 45 45 degree 15 minutes. Therefore, we will get 48 degree 45 minutes. So the correct answer is 48 degree 45 minutes. The correct answer. Therefore, option D is the right answer. Option D, 48 degree 45 minutes is the right answer. First of all, we have to find out the stations which are free from local attraction, and after finding that stations which are free from local attraction, we have to proceed the sums. Next question. A theodolite is set up at station A and a 3-meter long staff is held vertically at station B. Let's draw a diagram. A theodolite set up at station A. So this is A. A theodolite is set up at station A and the 3-meter long staff is held vertically at B. Meter is held at B. The depression angle at 2.5 meter marking on the staff is 6 degree 10 minutes. Depression angle. So it will be below horizontal. Depression angle at 2.5 meter. So it will be somewhere around here. So the total height is 3 meter and the depression angle at 2.5 meter is will be 2.5 meter. Equal to 6 degree 10 minutes. The horizontal distance between A and B is 2200 meter. Height of the instrument at the station A 1.1 meter. So from the height of theodolite, it is very clear that so the height of the instrument is just 1.1 meter, but the marking made at depression angle. So the depression angle made at 2.5 meter is 6 degree 10 minutes. So it will be it is very clear that 2.5 meter is at the depression angle. The depression angle is made at 2.5 meter and it is depression. So it is very clear that this will be at so the B the land at B is very below A and the RL of A is given as RL of A is given as we can take it as benchmark, that is 880.88 meter. Apply the curvature and refraction correction, determine the RL of B. So RL of B is asked. So to find out RL of B, we must know this distance. So x distance we have to calculate, and after calculating the distance of the height of x, and we can calculate the height of instrument is given as 1.1 meter. So the height at line of collimation is equal to height at line of sight or line of collimation is equal to 880.88 plus 1.1 will be equal to 881.98 meter. So the height at this point is equal to plus 81.98 meter. So to calculate the RL of B, we can subtract this x distance and minus 2.5 from this height at line of collimation, so that we will get the RL of B. And also one more thing, apply the curvature and reflection correction. That is, a combined correction must be applied here. Combined correction is applied here. In yesterday's problem, we have discussed a sum which neglects the curvature and reflection correction. But in this problem, they have told to include the curvature and reflection correction. So let's get into the problem. First of all, we will find out the height, that is x. So to find out x, we can use the tan degree 10 minute is equal to opposite by adjacent. So opposite is x. Adjacent is the distance between A and B, which is 1200 meters. So that we get x is equal to 237.701 meter. 37.701 meter. So x is equal to 237.701 meter. Now RL of B is equal to height at line of sight, minus x minus 2.5 meter, that is the staff rating, and minus combined correction. So this is the thing we have to include here. In yesterday's sum, they have told to neglect the combined correction. So we stopped the sum at here itself. We stopped the calculation here itself. If they have told to neglect the combined correction, we should not calculate this combined correction. So the height at line of sight is 881.9 minus x, that is 237.701 meter, minus 2.5, and combined correction is equal to minus this negative correction. So it is minus 0.0673 to d square into d square. D square means distance, that is distance between A and B, and it must be in kilometer. Must be in kilometer. 0.2 square. So after calculations, we will get the answer is equal to 642.105 meter. 642.105 meter, and it is lesser than B, lesser than sorry A. So it is lesser than RL of A. And from question itself, it's very clear that the height of instrument is just 1.1 meter, but the depression angle is made at 2.5 meter. So it is very clear that RL of B is lesser than RL of A, and we have derived the answer as lesser than A. From this, we can conclude that it may be right answer. In option it is given, uh, we would have confirmed the answer, but RL of B is lesser than RL of A. From that, it is very clear that we have arrived at the correct answer. So that's it for today. Tomorrow, let's see 2014 gate problems. Thank you.